So I'm obviously not at Mount Somers, but I'm here in my backyard to talk to you a little bit about Mount Somers geology. First, I'm going to give you a general overview of geology in the Canterbury region of New Zealand. Then I'm going to focus in on some of the things that make geology in the Mount Somers area unique, and after that I'll focus on some of the commercial uses of geology in the area. For most of my research here, I looked at TEARA, which is the Encyclopedia of New Zealand Online, and then the Department of Conservation's website's information on Mount Somers, and also some research done by the Geology Department here at the University of Canterbury. To begin with, the geological landscape in Canterbury is dominated primarily by the Southern Alps, which are mainly made up of 230 to 170-year-old greywacke. Additionally, Canterbury's landscape has been shaped by 5 major periods of glaciers. These glaciers carved out valleys and depressions between mountains, some of which are now basins filled with gravel or lakes. Fault lines and earthquakes are also key geological features of the Canterbury region, and the land has been altered by numerous earthquakes from fault lines where the Pacific Plate undercuts the Australian Plate. These earthquakes have caused things like rock slides, which reshape the land. According to TEARA, the Encyclopedia of New Zealand, farther movement along the Alpine Fault will continue to shape Canterbury in the future. Another significance in Canterbury, in addition to Mount Somers, which I'm about to get to, is the Banks Peninsula. The Banks Peninsula was formed out of basalt volcanic eruptions around 12 million years ago. Moving on to Mount Somers specifically, it, like Banks Peninsula, also has volcanic origins, which sets it apart from the rest of the Southern Alps. It does, however, still lie on the eastern edge of the Southern Alps. According to research done by University of Canterbury Geology Department, Mount Somers as a whole is actually made up of 7 upper Cretaceous volcanic formations that are temporarily considered extinct. One peak considered Mount Somers' summit is a rhyolite dome volcano. Together, all 7 of these form the Mount Somers volcanic group. It was shaped by volcanic formations of andesite and rhyolite and is made up of erosional and block-faulted calc-alkaline rocks. Block-faulted just means they were formed by large crustal blocks of earth either pushed upward or collapsed down when forces of the Earth's crust pulled it apart. 2 different fault lines have largely shaped Mount Somers, the Mount Somers and the Staveley faults. The presence of these fault lines is marked by the exposed northern and southern faces of the mountain. On the south side of the mountain that lies along Staveley Fault, the fault trace is actually visible in aerial photos for a few kilometers. According to the DOC's website, Mount Somers' composition of andesite, rhyolite, and pitchstone has caused its soils to be less fertile than surrounding land. This means that it is marked by a different fauna than surrounding summits. Now moving on to some of the commercial uses of geology in the area. Canterbury as a whole doesn't have a whole lot of mineral resources being used commercially. However, a lot of the minerals that are sourced here do come from the Mount Somers area. The New Zealand Department of Conservation website cites Mount Somers as a source specifically for sand, clay, silica, limestone, and coal. In the past, limestone was quarried there and exported to Australia, while silica sand was mined for glassmaking. Coal deposits were discovered near Mount Somers in the mid-1800s, and coal mines along the railway tracks used for transportation can be seen on walks in the area. Mining there continued for about 100 years, but was eventually stopped in 1950 due to a series of mine fires and the coal's low burning quality. Ultimately, it's very important to understand all of this because geology has a huge foundation and often underlying impact on what we see in nature. Geology both limits and defines how we're able to interact with the land. For example, as I mentioned earlier, Mount Somers' volcanic history has a significant impact on its soil quality. This in turn impacts the types of life that the area can sustain and the types of vegetation that can grow there. This is expressed in the amount of exposed rock and plant life that's actually pretty unique from the plant life on surrounding mountains. Had we gone to Mount Somers, we would have seen alpine vegetation, regenerating beech forests and even bog plants, which are unique and all turn back to the geological foundations of the area. To take all this even farther, these differences in vegetation also affect the kind of birds, insect, and other wildlife that the area can sustain. And what types of both flora and fauna we would have seen in the area. Additionally, it's important to understand the commercial and economic uses of land before interacting with it. A lot of that at Mount Somers comes, or at least used to come, from geology and mining. We very likely would have seen the remnants of that nearby. So to conclude, these combined geological impacts I've outlined can be seen throughout the Canterbury region as a whole. The impacts specific to the formation of Mount Somers, and from there the vegetation and man-made impacts that hinge off of geology. These all would have had a significant impact on the kinds of things we'd have been able to see and interact with on our trip, therefore shaping our experiences out at Mount Somers. Thanks.